Welcome to Ask and Learn.
So they give us this set 0, 1, 2, 3, and they want us to determine if those 5 relations that they give us is a partial ordering or not. Well, let's write out the definition of partial ordering really fast. So partial orderings have 3 properties. 1, it is reflexive, which remember means if little a is an element of S, then we have a in our relation R, and then this is going to be anti-symmetric, which means if A, B are in S, then if A, B or BA are in R, then A is equal to B. And then lastly, we want transitive, which means so if AB and BC are elements of R, then AC is also an element of R. So we just need to keep these in mind when we're doing this. All right, so let's check what we have here. And outside of just saying if these are partial orderings, they want us to tell which of the properties it lacks if it is not a partial ordering. All right, so let's see. So for this first one, so let's just check if it's reflexive or not. So we have 0, 1, 2, 3. Well, we have 0, 0, 1, 1, 2, 2, and 3, 3, so it looks like it's reflexive. Now, what about anti-symmetric? Well, we only have where it's 0, 0, 1, 1, 2, 2, and 3, 3, so we don't have any issues with that, so that one works out. And then the same thing with transitive. So this one will be a partial ordering. Okay, now what about this other set? So let's see if it's reflexive. All right, so we have 0, 0, 1, 1, 2, 2, and 3, 3. So reflexive checks. What about anti-symmetry? Well, notice here we have 2, 3, and 3, 2. So this fails. So this is not anti-symmetric. And then let's just see if it's transitive or not. Okay, so we don't need to check 0, 0, 1, 1, 2, 2, and 3, 3. Those are good, so we just need to check the other ones. So let's see. So when we have 2, 0, so there's only one value that this gets taken to, 0, 0, and then 2 zeros in there, so this one checks for transitivity. What about 2, 3? Well, 2, 3 goes to 3, 2, and so that would be the point 2, 2, which is right here, so that checks. How about this one? So we go from 3 to 2, and then we could go from 2 to 3, and then 3, 3 is also in there, so that one checks. So this is transitive. But so this one is not due to the anti-symmetry failing. All right, let's go to C. Well, we need to check to see if it is reflexive. So it has 0, 0, 1, 1, 2, 2, and 3, 3, so reflexive checks. Let's check to see if it's anti-symmetric. So the only other point it has is 1, 2, other than the reflexive ones, so that checks. And then for transitivity, so the only one we need to check is 1, 2. Well, 1, 2, the only thing this can go to is 2, 1, and so 1, 2 is already in there, so that one's also checks. So this is a partial order. Now, what about D here? So let's check if it's reflexive. So we have 0, 0, 1, 1, 2, 2, and 3, 3, so that checks. Let's see if it is anti-reflexive. Or not anti-reflexive, anti-symmetry. So we just need to make sure that, so if 1, 2 is in there, 2, 1's not, so that one's good. So 1, 3, 3, 1 is in there, and then 2, 3, 3, 2 isn't in there, so it's anti-symmetric. And then we need to check if it's trans or not, or transitive. So let's see, so if we go from 1 to 2, the only other thing we can really do outside of the identity ones is go to 2 to 3. So actually, let me kind of write that out. So we could do 1, 2, and then 2, 3. And so this would be 1, 3, and 1, 3 is in there, so that one checks. Now let's try 1, 3. So if we do 1, 3, actually the only thing that can go to is 3, 3, so that one's fine, so we actually don't need to check that one. And for 2, 3, the only thing that can go to is 3, 3, so that one also checks out. So this would be transitive as well. So this is a partial ordering. All right, so now let's see about E here. So is E reflexive? Well, we have 0, 0, we have 1, 1, 2, 2, and 3, 3. So reflexive holds. Is it anti-symmetric? So let's see. So we have 0, 1, but we have 1, 0. So this is going to fail here because we have 0, 1, and 1, 0. So that fails there. Does it fail for anything else? It also fails for 0, 2, and 2, 0 also. But we only need to say 1. Now let's just check transitivity to see if this is or not. So if we do 0, 1, so let me actually write these out. If we do 0, 1, this can get taken to 1, 0, which 0, 0 is in there, so that one's good. We don't need to check that. What about 0, 1, 2, 1, 2? So that would be 0, 2, which 0, 2 is in there. So then let's see, 0, 1 there. Okay, so yeah, those are the only ones for that first one we could do. Now what about 0, 2? So let me put a little dot there to say we did that. So we'd have 0, 2. So that could go to 2, 0, which would give us 0, 0, which is in there. So that's good. What about 1, 0? So 1, 0, well, there's actually nothing for this because there's no other ones outside of 0, 0 and 0, 1. Or actually, no, we would want to check 0, 1 for this actually. So that would give us 1, 1, which is in there. All right, now what about 1, 2? Well, here we have, so which ones start with 2? So just 2, 0. So 2, 0, which gives us 1, 0, so that one checks. So we're done with all these. Now what about 2, 0? So we have 2, 0, so we have 0, 1 there. And so this one is going to fail because we don't have the point 2, 1 in there. So this is also not 1 due to anti-symmetry failing as well as transitivity. So this is kind of the process you would go through to check to see if it's anti-symmetric, reflexive, and transitive.